Hello. Now we would like to have a discussion this time on the concept of how we get the sum or what we get when we add algebraic expressions. Now what we have seen previously is that when we add algebraic expressions, generally they are a description of how a calculation has got to be done, the steps to follow basically, and which order, which format are we going to take. Okay, so that gives us what we call algebraic expression. Okay, very much a description of how a calculation must be done and in what order. Okay, how do we do this calculation? Well, when it comes to calculation basically reduces to adding, subtracting, multiplying, and later dividing. And we would like to start with adding. How do we add algebraic expressions? How do we deal with this type of expressions, which we call algebraic expressions, when we have one quantity being added to the other quantity? So right away, I will be sharing with you a screen which is going to contain the what? Which is going to contain the question, which is going to guide us through this process of adding algebraic what? Expressions. Now, the question or the screen I shared with you has got questions specifically for adding what? Algebraic expression. Now, the first question here, or even before we move into these things of adding, how do we deal with the technical detail of adding? Well, we say to add two or more terms, let's say one terms each, like one terms that are like terms, because generally that is what is going to reduce to. When you have an algebraic expression that you have to add to another algebraic expressions, you will have later to do what is called grouping. Grouping then means we take quantities or terms that are like, that looks alike, in the sense that if there is one term with x, then we put it close to the other terms which has got x. If there is another term with x squared, we put it close to the other term which has got x squared. If there is a term without x, we put it close to the other term without x. Then when we do that bit of grouping, then we look at the sign of multiplication or the sign of addition which is between them. That's how we do the grouping. So we say to add two or more monomials, that is quantities or expressions that each has got one term that are like terms. We add the coefficient and we could keep the variable on the what? We keep the variable and the exponents, if there is an exponent on the variables, the same. Well, what this description is trying to say here is that if, for example, we have, let's say, x, if we have, for example, x, that we have to add to another quantity, say 2x, what we do is we deal with the coefficient. With coefficient here, we means the number which is standing before the letter x. Now, notice that the number which is standing in front of the first letter x is some silent one, which is not always, written there. So we add this one onto what? We add this one onto the other two, which is standing where? Which is standing right in front of what? Which is standing right in front of the second x, this one. So we add those numbers in front, which we call the coefficients. So when we add 1 to 2, what we get is a 3. Then we keep this variable, which in this case is x, without, changing anything. Now, should it happen, according to this statement, should it happen that we are dealing with a number which has got an exponent, let's say this time we are adding, for example, 5x squared. So this time, what are we adding? We are adding 5x squared to some other quantity, which in this case is what? Some other quantity, which in this case, for example, is, well, 2x squared. This is what we are dealing with this time. So now we're having 7x squared, rather, we have 5x squared that we have to add to 2x squared. Now, these quantities, as you can see, they are monomials. They are like 1 terms each. The expression, the first expression is 5x squared, and the second expression is 2x squared. Now, this way, what we are going to do is we have to add the coefficients. We have to add the numbers which is standing right in front of these x squares. And what will this give us? Now, notice that the coefficient of the second quantity, okay, this coefficient of the second quantity, right, sorry for that. Just okay, so now what we are going to be doing, what we have then to deal with is the fact that we have to add the numbers which is standing in front of these coefficients, rather the coefficients themselves, sorry for this. The coefficient here for the first case is, this other one is 2 and the other coefficient here is 5. So let me just highlight it so that it's easy for you to see. We have a 5 here, and also there is this other one which is right there. Now notice that what we have here is that these coefficients are the numbers that we are going to add, okay? So notice that when we add 5 to 2, we get a 7. Now we don't do anything, we don't disturb the variables, which in this case is x. We also don't disturb the exponent of these variables, which in this case is what? Is 2. So what are we going to have? Well, we are going to be having 7 what? 7x squared. So 7x squared is what we are going to be having as our what? As the final value of what? Of the sum of 5x squared when we add to 2x squared. So this is what we get, and this is the answer. Now, this has been just, the basic case. Now, the question here is, what if we have a case as given here? Now, here we are supposed to find the sum of each, okay? So notice that this is being added to that. They are separated by these brackets. And we have to simplify our answer. How are we going to deal with this then? Well, let's start with A. Now, this A has got 2x squared plus 4x minus 8. So we'll write that down, 2x squared, 2x squared plus 4x minus 8. Now, this is in a bracket. Now we have to add this to the second what? The second expression here, which you can see for yourself, x squared minus 3. So we'll be writing it down, that is plus x squared minus 3. Yes, that's what we are dealing with. Now, what we are going to do at this point in time, okay, what we are going to do at this point in time is to what we are going to do at this point in time is to do grouping, also known as collection of like terms. Now, collection of like terms means the terms or expressions that are similar are grouped together. Similar in the sense that if one has got x, the other one also has x. If one has got x squared, the other one also has got x squared. And if the other one has got a constant, then we group it also as a constant. Now notice that this other one here, in fact, notice that this is similar to this other one. In other words, they look alike. Okay, so we will put them together. So we will be having 2x squared. Okay, we will have 2x squared, 2x squared. So this 2x squared, we are going to add it to x squared. Okay, we are going to add this to x squared. Now, what is remaining is 4x, then -8, then -3. So what we are going to do with these is, since we don't have any other quantity or any other term similar to 4x, we will just keep it as 4x without any problem. So well, let's have that down as 4x. Now the other thing is this 8 here. Now notice that this 8, well, let's include the sign in front of it. Notice that this 8 here, which I'm giving it some other color, is similar to this other 3. Similar in the sense that none of them do have x. So we will be having -8 that we have to place close. We'll be having what? -8 that we have to put close to -3. Okay, so what we have done here is we have collected like terms. Now after this, the next thing that we want to do is to add the numbers in front of these variables, the coefficients of these variables. So we will start with the x squared. For the x squared, what do we have? Well, we have 2, okay? We have 2 right here. 2 is in front of x squared. Also, we have, there is this, a silent one, which is in front of what? Which is in front of x squared, which is the second x squared. So what we will do in this case is we will add this 2 to this 1 to get what? To get 3. Now, we will keep x squared the way it is. We will not tamper, we will not do anything to the exponent, we will not do anything to the variable, we just keep it the way it is. What we do is we add the coefficients. Then notice that we don't have anything similar or looking alike to 4x. So we just keep it like that as 4x. Now notice that we have -8 or -8 minus 3. Now that we can do what? We can calculate it. -8 minus what? -8 minus 3. So we have -8, oh sorry, -8 minus what? Minus 3. What do we get for that? That is going to give us -11. So we write here -11. And yes, this becomes the answer to question A. Question 1 part A. Now the next question is question 1 part B. Now in question 1 part B, we have been given what? We have been given 10x cubed minus 4x plus 11 that we have to add on to 9x cubed plus 2x squared minus 2x plus 4. How do we deal with this? Well, let's do that right away. So we have got 10x cubed. So we have what? 10x cubed. Now notice that this 10x cubed has got to be added, rather minus 4x first. Minus 4x plus 11. These are the items in the first what? In the first bracket. We have to add this onto the items in the second bracket, which include what? 9x cubed. This is 9x cubed. Now this 9x cubed is also being added to 3x squared. It's being added to 3x squared. And then we also have what? Minus 2x. Then finally plus 4. Well, the question here is, how do we deal with this type of grouping? How do we deal with this type of expression? How do we add this algebraic expression? Now, notice that we have x cubed and the number in front of x cubed is 10 here. And also the number in front of the second x cubed is what? Is 9. Now, these two are like terms. Why is that so? It's because all of them has got x cubed attached to them. So we will do what is called collection of like terms. We group them together. So grouping them together means what we are going to do is, what we will do is we put them together. So we'll be having what? We'll be having just close this. Okay, so yes, we'll be having 10x cubed. This 10x cubed must be added to what? We'll first get it close enough to 9x cubed. That's what we have for 10x cubed. Now after that, we have to add this to 9x cubed. Why are we adding and not subtracting? It's because the sign in front of 9 is a plus sign. And so we keep that sign the way it is. Now, at least we have done that. The next number here is 4x, then 11. And also this side, we have this. Now notice that in descending order, we would like to have from x cubed, then x squared, then x. So we would like to include the terms involving x squared before we go to that with x. Now notice that there is only one term with what? With x squared. And so that's what we are going to do. We will just pick that one and we put it right here. There is nothing that we have to add on to it. We don't have any other like terms, just like this 3x squared. And so we will keep 3x squared the way it is. So keeping 3x squared the way it is, we'll be having write this down here. 3x squared. Now that's what we have got so far. The next thing we want to move to is now the term with x. Now notice that even when we are doing grouping, we want to follow the pattern that the quantity with the highest exponent comes first, then followed with the one with the what? The second highest and the third highest. In this case, the quantity with the highest exponent is x cubed, then followed by x squared, then followed by x. That's the reason we brought 3x squared before we could bring the 4x and the what? And the minus 2x. Now the other thing here is this. We have this 4x. Notice that this 4x, which we are talking about, is similar to what? Is similar to this other one here. Why are they similar? Well, they are similar because all of them have got a single x attached to them. It's not x squared, it's not x cubed, it's just x attached to them. So we would like to put them right away next to 3x squared. So we will be having 4x. But notice that the sign in front of 4x is a minus sign. We don't want to leave that. We will also be bringing it. Then the next thing we want to bring is this other 2x, which is what? Which is also having a minus sign in front. Now the other quantity remaining, the other term left this time is what? Is this other one here, which is now 11. 11 does not have any x attached to it, just like what? Just like 4. So what we are going to do is, at this point in time, we will now add 11 onto what? We add 11 onto 4. What we have done is called collection of like terms. We have grouped these terms that are alike together. Now, what else after this? Well, after this, we now do what? We now add the numbers right in front. So notice that in this case, we have 10, which is standing in front of what? 10 is standing in front of x cubed, okay? 10 is standing in front of x cubed. And then we also have what? We also have 9 is standing in front of x cubed. So what that means is we are going to have this what? Okay. Yes, we are going to add this 10 to 9 so that we get 19. Then now we will just keep the what? We will just keep the x cube attached there. So this is what we are going to have. We will keep the x cube attached there. Just like that. Then we now move to what? To x squared. For x squared, we have only one quantity. So we just write that because there is nothing that we have to add onto it. So we'll be having 3 what? 3x squared. Then after that, we have this 4. The 4 has got what? This 4 has got a 2 attached to it. And so what we are going to do is we will get the number right in front and we add it to the other number right next after. What this means is we are going to have -4 minus 2, which is what? Which is -6. Then we keep that x. We add only the coefficient. All right. Then after that, we have this 11 and the 4, which gives us 15. And yes, this is the solution to this question. Now notice that after grouping that like terms, getting the x cube and the x cube together, the x squared and the x squared together, the x and the x together, and the constants together, you can now add the number standing in front of the variables, which we call the coefficient. In this case, we added 10 to 9 to get 19. We did not have any other quantity like x squared to add this 3 to, so we just copied the 3x squared. Then next we added what? -4 onto -2 to get -6. And finally, we added 11 to 4 to get 15. And yes, this is how we would add these two quantities. Now, the next thing we want to look at is C, okay? Now, in C, we do have what? We do have this expression here that we are adding onto the other expression. Now, notice that I will do up to C, then D, E, and F is going to be your task. So there we go. Watch this last part carefully so that you don't miss on your exercise. So C is saying that we add, well, the first expression or the first whole thing here is what? Is 20x raised to power 4, 20x raised to power 4. X raised to power 4, that is 20x with exponent 4, minus what? Minus 3x cubed. Minus 3x cubed. Then plus 2x squared, that is plus 2x squared. Then onto this 2x squared, we also have to add x, that is plus x. Then finally, we have -5. Yes, that is what we have inside the first bracket. We have to add this onto the other second what? Onto the second expression in the second bracket. So we are going to be having plus, that is for the addition. Let me even highlight it so that it's clearly indicated there that this is purely for addition, okay? Yes, now we have to add this to what? We have to add this to 14x with exponent what? 14x with exponent 4. 14x with exponent 4. Then what else do we have? Minus 7x cubed. 7x cubed. Okay, then what else do we have? We also have plus 12x squared. That is plus 12x squared. And then finally, what do we have? plus 2x minus 9 plus 2x minus 9. Yes, this is what we have. Now, I'm just going to reduce it a little bit, the font size, so that we can have it in one line. Yes. So yes, this is what we have. First thing first, collection of like terms, meaning grouping terms that look alike together, terms that have got similar variables together. Similar in the sense of x cubed, x exponent 4, x squared, and just x. So you see this 20 here, we have to group it together with what? We have to group it together with this other 14. Why is that so? Well, it's like this because they all have x exponent 4 attached to them. So in the next step, what are we going to have? Well, in the next step, we are going to be having 20x exponent 4 that we have to add to what? That we have to add to 14x with exponent 4. Yes, that is our first step in the collection of like terms. Then now we will move on to x cubed. So we have a minus 3, okay? So we'll be starting with the minus 3. Minus 3x what? Minus 3x cubed. Then we also have a what? A minus 7x cubed here. Minus 7 what? X cubed. So what will this be? Well, we will then move on to a plus 2x squared. That is a plus 2x squared. Now this 2x squared has got to be added onto what? Onto this 12x squared. So we have plus 12x squared. Yes. Now after this, we then move on to the x here and we add on to this 2x. So we have plus x, then plus what? Plus 2x. Then we move on to this minus 5 that we have to add onto what? Onto this minus 9, like that. Well, in the next step, after reaching here in the next step, now that we have these like terms grouped, we then add the numbers in front. So here we will be adding the coefficient of x with exponent 4 and also this other one here. So notice that when we add 20 to 14, we get what? We get 34. So that would give us 34 with exponent, that is x with exponent 4. We don't do anything to the exponent, we don't do anything to the variable, we just add the coefficient. Notice that when we add negative 3 to negative 7, we get what? Negative 10 exponent 3. Now this is something you can also use a calculator in case it's a little bit difficult for you to see. You can have your calculator and you'll be like negative 3 minus 7. So you'll be writing negative 3, okay, minus what? Minus 7. And that gives you negative 10. Yes, that's how we got this one. Then now we move on to the component of x squared. So we have to add this 2 right here onto the what? Onto this 12 here. Notice that when we add 2 to 12, we get 14. So that will give us plus 14x squared. Yep, that's 14x squared. And then lastly, we have this x that we are adding to 2x. Notice that this x has got some silent 1 in front. And so we would like to add that silent 1 onto what? Onto this other 2x. So notice that when we add 1 to 2, we get 3 of x. Then from 3 of x, we now have minus 5 minus 9 is minus 14. And yes, this becomes the solution to exercise 1 part C. So please make an effort to go through this and check to ensure that you have understood all the steps, and then make an effort to do the remaining part D to E to F. Then when you are done, also, don't forget to do what? To submit your activity. And that's where we are stopping for now.